All right. Hello, everyone. Welcome. We're gonna start in 1 minute. I'm just gonna wait to see if everything is okay. If microphone is okay or and the music volume. So please let me know if anything is wrong. And we'll begin after that. So I'm just gonna write 1 minute. I wonder if my graphics tablet is working because I tried starting it, using it, but for some reason it doesn't want to work. And drawing with mouse is not great. Yeah, it's connecting and then immediately disconnecting. I suppose I'm gonna just do it with mouse, which is fine, I guess. Okay, so contributing to PixiEditor. Today I'm gonna show how to create a node. I will try to walk you through like the general architecture and the PixiEditor internals. I think it's pretty interesting. We'll try to make a mirror node, or more like flip node. So basically a node that will take, like, for example, an image and flip it like this. But of course not the viewport, just like I did right now, but the actual image. So this is what we will try to do today. But the very first thing that you need to do is to set up the environment. So the very first thing is to go to PixiEditor.net/docs, and then there is like everything you need to know to set up the project. So PixiEditor is a desktop app written in and almost entirely in C#. So you need .NET, .NET 8 actually. Yeah, the 8 in the 8th version of .NET is actually important. The newest is 10, but our extension system doesn't work with 9 and 10 yet, so .NET 8 is required. So go to .NET website, download the SDK for version 8, and follow this guide, because it contains almost everything you need to know to set up your project. I'm not gonna do this because, well, it's written down, and we can focus on more interesting stuff. So once you get your development setup ready, I'm gonna use Rider, but Visual Studio works fine. Visual Studio Code is also okay. I'm not a fan of using Visual Studio Code for C# because it requires a little setup to get comfortable with, but overall should work just fine. So once you open PixiEditor solution file in your editor, you're likely gonna see this. So a root project called PixiEditor. It has 55 projects inside, and this root solution folder contains a lot of smaller ones. We're not gonna focus on every single one of them because it's not important. The ones you actually gonna care about are 2 or 3. They are in the core folder. The core folder contains everything required to run PixiEditor, like the very base of PixiEditor. The rest is associated with some other stuff. So yeah, in the core folder, the main project, the project that contains the, like, glues everything together, is PixiEditor, just PixiEditor. By itself, this is not a app yet, it's just a library. If you go and check the source CS project file, you will see that this is not an exe, this is not a console app, it's just a library. Because by design, PixiEditor should be able to be run as a desktop app or a web app, and even technically mobile. I mean, it's possible, though of course there is no PixiEditor for mobile, and likely not very soon. There is a browser project, PixiEditor.browser, which technically should run PixiEditor in browser, but it's not gonna work, and likely it's gonna throw you an error because there are some issues. It's just there because maybe one day we're gonna adjust PixiEditor to run in the browser. So it's more of a placeholder. You can even hide it if it causes issues for you, or rather unload it, where there is unload project. So we don't need it. The PixiEditor.desktop is like the XZ actual app that is running. It contains very little stuff. It's just an app, favicon, and a setup code program. PixiEditor is written in Avalonia UI framework. So it is a cross-platform framework for .NET. PixiEditor is running on, of course, macOS, on Linux, and Windows. It should work on all of these platforms, so you can compile it anywhere, I hope. And yeah, so we're gonna care about the main PixiEditor today, and PixiEditor.changeable document. So I'm gonna now explain a little about the overall architecture of PixiEditor. So let's go to PixiEditor and let's do some drawing, hopefully understandable drawings. PixiEditor's architecture looks a little like classic web app architecture, but only in the abstraction way. It has nothing to do with web technologies. So in a way, there is a frontend, which is a GUI. I'm gonna call it a GUI. Let's use a text maybe. GUI. And there is a second thing, which is a backend. So a backend is like, it knows nothing about the GUI. It knows nothing about the UI part. It's just this core that draws, that saves data, that defines how Pixie document looks like, and all of this stuff. So I'm just gonna call it backend. But in reality, this is called changeable document. This is PixiEditor.changeable document. This is the backend. So these two communicate with each other, like this. GUI is gluing the whole app together with the backend and all of the other stuff, and all of the GUI part of the app, the front end, is making calls to the backend, which backend processes, of course, and returns the state of your document, information about changes, and so on back to the GUI, which is again PixiEditor. This is the GUI or frontend. So this is a very broad description of how the data is passed through, because there are a lot of other stuff that I'm not gonna dive into. Generally, PixiEditor uses MVVM pattern for the front end. So anyone who's familiar with the patterns of GUI patterns, this should be familiar. MVVM is basically referring to how the UI code is, let's say, talking with the actual code that contains data. But we're not gonna make any GUIs today, so I suppose this is just a information that you can put in the back of your head and maybe come back to it later. For the record, all the GUIs are made in Avalonia UI by using the example files. example files is basically a XML, something like that, with properties that describe what should be put. So yeah, here we have example GUI, which is a all controls panel. It contains a lot of different controls that doesn't do much, but basically you can open it and see how you can create GUIs in PixiEditor. And yeah, that's for the GUI part. So maybe let's create a node, because it's gonna be fairly simple. Creating a node is a simple process. We're gonna need two files. So for a node, we're gonna need two files. One of which is in the backend. It's gonna be the actual implementation. Let's call it Node.cs in the backend. And one in the GUI part, which basically is a mirror of what you've created in the backend. But it contains some metadata about how it should be displayed, the icons, the descriptions, and some custom configuration for the GUI. So it's gonna be node viewModel.cs, and this will be in the GUI. Basically, two of these, and you have a node. You can use it and try it out. So let's do it. Yeah, the very first thing to do is to create the node.cs in the backend. But where? In the changeables, PixiEditor.changeable document, changeables, graph, and nodes. Yeah, PixiEditor.changeable document, graph, changeables, graph, nodes. So here we have all the nodes that PixiEditor has in its current implementation, in the current version. So let's create a new one. In the nodes folder, I'm gonna create a, let's call it a flip node, because we're gonna make a flip node today. Here we have our flip node. It's just an empty file for now, class. So one thing that each node needs is to inherit from a node. So public class flip node inherits from node. Of course, node requires implementation of a few stuff, so let's implement them. I can use in the rider an option to implement missing members, but if you don't have this, you need onExecute, protected override void onExecute with a render context, and also public override node create copy to create copies. We're not gonna use anything fancy in the copy, so we can just return new flip node, and it should work just fine. We can now forget about this thing. And in onExecute, we're gonna need something. But before we do this, let's make it so it appears in PixiEditor. One more thing we need to create is node info. Node info is like a internal metadata that is required. The only thing that node info has is unique name. Each node requires its unique name. We're gonna call it flip because it's unique across the project. For example, in the folder node, we have folder. In the layer node, in the image layer node, it's image layer, and so on. So now we have everything we need in the backend to display PixiEditor in actual app, but the frontend does not know about it yet. So let's make it aware of it. So in PixiEditor project, I'm gonna go into view models, because we're gonna make a view model for a flip node, basically. So in view models, let's go to document, as far as I remember, nodes. Oh yeah, PixiEditor project, view models folder, document subfolder, and nodes subfolder. Nodes in the front end need to be on the same structure as in the backend. So if in the backend you've put, let me see, you have put the node, for example, flip node in the root folder of nodes, you need to do the same in the front end. So if I move the flip node to, for example, shapes, it would have to be in the shapes folder in frontend too, because PixiEditor automatically detects the view models for each node. So let's create the view model. Flip node view model. The name is important too. It needs to be the name of the node plus view model, basically. So we have flip node in here, and we need to add view model. So let's do this. And this class does not need much. Basically, a node view model. It needs to inherit from node view model, and as a parameter of this class, generic class, we need to put the flip node, basically. So it basically says, hey, I want to create a view model for our node flip node. There are a few constraints here too. So as you can see, it's underlined on red in the red color. Because node view model is not public, and we are trying to make the flip node view model public. So to fix this, it's just a matter of setting it to internal. Okay, and one more thing. Flip node view model also needs a attribute. So it's node view model as well, the same name as here. And here we have some metadata that we can configure. So for example, display name, it's gonna be flip. Let's put it into a root category for now, or even null. So it will be in the MISC category. No icon, and yeah, let's run PixiEditor. It will probably crash. Oh, I have some issues. I think I need to clean the project, because yesterday I was doing some changes. So let's clean everything. Hopefully it will work. I'm on the master branch actually, so it should compile. And it does not. Interesting. Alright, let's debug. Debugging time. This is also important because sometimes there are some issues. So assets file doesn't have JSON object. Okay, maybe let's regenerate everything. So I'm gonna open it in the Explorer. Oh, you cannot see it, but it's fine. I'm just gonna delete some stuff. So it's changeable document.gen, PixiEditor, src, changeable document.gen. Okay, let's remove the object. And now Pixie parser. All right. Pixie parser is a library for parsing PixiEditor files. It's on the separate repository because I want to publish the latest version as a NuGet for your project as well. It was already published for version 1.0, but for 2.0 not yet. Okay, so what we have: extension common API diagnostics, objects. Oh, so many stuff. Let's remove it. Okay, PixiEditor.gen. All right. And WASM-API.gen. I should have checked before the stream if it works. It would save a lot of pain. Alright, let's try again. Let's rebuild everything. Okay, still it has problems. Interesting. It requires maybe we need to restore NuGets packages. It's actually good that it happened on the stream, because this way you can see how the issues can be resolved, as long as I'm gonna resolve it. I don't know, sometimes .NET likes to this kind of stuff, although it's not just a problem of .NET. Like every language and every bigger project usually has more complex build steps, and yeah, debugging weird errors is a normal thing. Alright, no errors so far. which is good. Oh yeah, it built. Okay, let's run it. Seems like it's gonna work. Oh, yep. Alright, I have opened PixiEditor, so I'm just gonna close it because it likely is gonna complain that I have two PixiEditor instances open. Okay, here we have it. Our PixiEditor with custom node. Let's see if it's there. Spoiler, it's probably gonna crash because we did not implement anything in the node. So how did we call it? Flip. There it is, flip. Our beautiful blobless, bodiless node, which contains absolutely nothing. Yeah, let's add something to it. Let's make it work. So in our flip node, we have this unexecute, which basically throws an error for now. So let's make it not throw an error. Let's write something to the console, for example. Console write line, our hello world, or hello PixiEditor, maybe. There we go. And now to actually connect this node to other nodes, so we can even execute, I'm just gonna add a input. So to add an input, we need to define an input property. Actually, you know, I'm just gonna use render node for now, so we're not gonna focus on creating inputs yet. So we can ignore this for now, but in short, render node basically has some boilerplate for creating nodes that do something. We're gonna use it soon, but I'm just gonna create it just to show you how that you can connect your custom nodes. So we need to restart because I've changed the type. Hot reload usually works, but mostly for stuff that are good for hot reloading, like changing the body of onExecute. Okay. You have any file? It's now time to search for a flip. Oh yeah, there it is. Although it only contains output. I mean, this is good. If we connect it now, I'm just gonna put a console in here so we can see that there should be a hello PixiEditor in the console now. There we go. Here we have it. Custom nodes is working. Okay, it says hello all the time. Great. Yeah, let's make it better now. So it does something interesting. So it works with our files or layers. Yeah, okay. So now, inputs. There are many different input types. The best doc on this is on the PixiEditor docs in the usage, node graph, and getting started with nodes. I really recommend reading the documentation with the node graph topic, because there are a lot of useful stuff. In the property sockets, there are all the info about each socket, the color, what it does, and so on. We'll be interested in which one? This painter socket. Not paintable, this is something different. Painter. Oh, there it is, painter. Painter socket is a socket that basically allows connecting something that renders into different thing that renders. So in this case, on this image, there are orange painter sockets, which connects from output to background, and then on layer 2 from output to background again. The painter socket basically like connected like this creates a chain. So first, new layer draws something on the canvas, then layer 2 draws something on the canvas, and then it is passed to the output. It's not a texture, it's a painting action. So connecting orange sockets creates a chain of painting actions, basically. So let's create a painter socket. So public input property, or even easier. Okay, let's stick with input property. Input property allows you to define an input property with any type. You can put a bool here, you can put a, I don't know, double or even object as a generic input. But we are interested about the painter input. So I could do painter and give it a name, for example, but there is something in PixiEditor that already makes this a little easier, which is a render input property. And we can give it a name. Great. But we still need to create it. So we need to create a constructor. Click node. So we have a input, which is not yet initialized. And now input equals new render input property. It requires a few things. Basically a node. But we could fill everything in here. So node, basically a node which this input belongs to, internal name, display name, and default value. But there's an easier way, which is create input, create render input actually. This function only requires two parameters, one of which is internal name. So let's give it a name input, for example, or image. Let's call it image, so we'll know what image to flip. Lucas, morning, and a display name. Image to flip, yeah, that's a good name. No, it's a bad name. I thought it's a description for some reason. Yeah, it's just an image as well. Yeah, so let's see how it looks now in PixiEditor. It's still gonna compile show hello PixiEditor because we did not change on execute or anything. Okay, let's go to the node graph, and now flip. Oh yeah, as you can see, we have now a node with painter input and painter output. Output is added automatically by render node, by the way. I did not create it manually in this class, but it's in the base class. It will not do anything, but I can create a chain. So now again, hello PixiEditor. All right. So here we go. Let's remove the hello PixiEditor. I can even remove on execute because we are not interested on execute now. I'm gonna explain why in a second. There is this on paint, which is defined by the render node. So on paint, we can actually write code that does something to the image or a painter. There is this render context input, which basically passes data to this node about how it should be rendered, what is the context of this render, the opacity, and so on. The canvas is a target surface on which this node should write, paint. Yeah, so it's basically Skia's surface. So if you're familiar with Skia Sharp library, you're gonna feel at home very quickly. It's, to be really precise, it's Drawy. So we've created a custom library called Drawy. You can find it in libs, Drawy. It takes all the hard work of rendering things, and Drawy is basically a Skia's wrapper. So here you have a Drawy surface, not Skia surface, but in reality it uses Skia under the hood. Oh, okay, after this long introduction, let's do something finally. Surface. Let's flip our image. Or maybe before we flip our image, let's just draw something, just to see what we can work with. We can call surface.draw, for example, surface.draw circle. We're gonna draw a circle. The circle is gonna be at, I don't know, 32 and 32. So, oh yeah, we can use vectors. Okay, yeah, no, just let's come back to 32 by 32 floats and a radius of 32 as well. We need to pass a paint too, or we don't. No, I think we need to, yes. So let's create a paint. Paint is a object that describes how the circle should be painted. So let's create paint and let's give it a color. So we can basically tell Drawy to color a circle of, for example, colors aqua. Why not? And let's pass this paint. So here this line says, draw me a circle on this surface at position 32 x and 32 y with radius 32 and with my paint above, which has a aqua color in it. Let's run it. I don't know what NVIDIA did, but there was an update which basically shows this rectangle in the top right. It was never before in PixiEditor. I don't know why it didn't show and why it shows now, but when it is showing this NVIDIA overlay thing, PixiEditor freezes for 3 seconds. I don't know if it's on production, or I mean on the actual app that is released, or just on the development debug configuration, but it's a little annoying. Please fix NVIDIA. Okay, let's test our flip. The image is not required right now because we're not doing anything, so let's just connect output. Oh yeah, beautiful. We have our circle. It's hard coded, so I can't change anything yet. But yeah, we have our rectangle. Interestingly, you can see that in the preview, it looks a little different than in the output. It's because the previews are basically per node. They are not aware of the canvas you are drawing on. I mean, they can, but they are not by default. So here it has a bigger surface, I think 300 by 300 pixels, and our render node just tells, hey, please draw me a circle. So it draws a circle the best it can and then scales it to fit the preview. So it's different in here because output is actually aware of the document size, so it's more pixelated. You can overwrite previews so it looks exactly the way you want, by the way. Okay, but circles are cool, but we need to flip. This is how our node is called, so let's flip. Okay, let's remove everything, and now we have our input, so let's use it. But how to flip it? Good question. We are not gonna write any algorithm that does flipping like pixel by pixel. We're gonna use the power of matrices. So I'm just gonna very quickly show how it works. Matrix in computer graphics is it's everything. Without it, nothing here would be possible. Like rotating, moving, skewing. It's all matrix operations. Don't worry, you don't need to know how to, calculate matrices by hand. You just need to know how to use them to make them actually work. So it's not that necessary. Also, it sounds scary, but it's really not. It's not scary. So flipping operation with matrices is basically scaling by -1 in one direction. So like this. This is just says like scale -1 Oops. Here it is scaled by -1. If I put here 1, it would be normal. I can even show it with the node graph to be really precise. So there is a matrix node, the scale node, and let's put our image in here into scale node, and let's scale it by -1 and put it into the output. Nothing shows because we need to specify center, so let's put center position and see the split. Again, let's put it in here, and let me show it again. 1, -1. Math is beautiful. Yeah, let's go and do it then. So let's go and take our surface and save it. Let's save surface. Why? Because saving surface lets us do some operations like matrix operations, rotations, scaling, clipping, and so on. And after we finish doing it, we can just call surface.restore, and our surface comes back to our original state. Of course, we've already drawn stuff, like whatever you have drawn between save and restore, it's gonna be saved. Yeah, this is why it is even here. So let's go and call surface.scale -1 and 1. It's still not gonna work, but I'm gonna show you why. Oh, I think I already did in here. Oh, I closed PixiEditor. We are not specifying a center in here. This is actually quite important. So let's maybe hard code it now. We're gonna use 64 by 64. So in here. But this still is not gonna draw anything because we are just scaling the surface. We're not drawing anything to the surface. So to draw something, we need to use our input in here. So let's take our input and let's take its value, input.value, and paint. Let's call it paint. Of course, we need to check if it's null, so let's create let's make it this. Now it should work. There's one thing that might not work, but we're gonna see. I don't remember. Of course, if I'm explaining things too fast or something is not clear, please let me know in the chat. I'll be more than happy to repeat or explain something better. Oh no, 64. Okay. So clip. And let's check if it works. Perfect, it works. It's transparent because we have transparent layer, so can't say it's not working, right? But okay, let's draw something. All right, it's not clipped, that's for sure. So something went wrong. I wonder if we move it a little. No? Okay. So let's debug. We're saving the surface. Okay, we can even be a little more precise and save it into a integer. This is a number we can come back to by using restore to count. Save. It's not that important. I think the normal save and normal restore would work, but I always do this way because I feel safer for some reason. Yeah. Okay, scaling. -1, alright, 1. And px, px, and py, 32 by 32. It definitely works in a way that it draws something, because as we can see, there is an output. But let's make a test. Let's just make it, comment it out, and let's see if it draws. I think it will, but we'll see. Ah, of course, cannot hot reload everything. Hot reload works usually, not always. I don't know if it sometimes works, sometimes not. I don't know if it's a riders issue, so they're pushing an update, or it's a Windows issue. hard to tell, really. Okay, let's do it again. Flip. Okay, let's draw something. Okay, yeah. So nothing draws. This is to be expected, to be honest. So let's come back to our input and let's recommend it. Nope, still hot reload. It's not working. Okay, I see already where the bug is. I wonder if you can see it too. But here we are drawing whatever is in the input and then scaling, not the other way around. So it's a matter of flipping our logic. I hope. Okay, let's go, let's flip it. Oh yes, our flip node is working, perfect. So of course it doesn't work for bigger canvases, or it works a little unexpectedly, because it clips in here for some reason. I wonder if it's a layer issue. I don't think it is. I think it's our nodes issue, but let's recreate it just to be sure. Yeah, oh. Yeah, no, it's not an issue of the layer, but it's just a matter of us hard coding the center value. So let's maybe make it less hard coded in here. Our context contains useful data that we can use to make it work better. So there is a document size which we could use, but there is also a render output size which is even better, because PixiEditor can contain multiple viewports which are part of the same document. So if there are two viewports of two different sizes in the same document, the document size will be the same, but the actual render size will differ. So we're gonna use render output size. And so let's do it. And I keep clicking hot reload. Maybe, oh yeah, I'm using release. Of course, I'm not using debug. Maybe now it hot reload will work. Oh, okay, but now wow, I wonder if I come back to the release it will work. Compile. Oh my god, okay. I need to do this again. Lovely. I wonder if I just do tools, NuGet, force restore. Would this work? It's now rebuilt. Oh great, seems that it will work. I'm glad I don't need to remove the object folders again. That was annoying. Restoring NuGet is good, it's good. Alright, let's run it and check if it works. Next thing that we're gonna do to this node is add an icon and localize the text. But let's see if it works. So, okay, let's leave it at 64 by 64 and see. Oh no, not loud. Flip. Okay. Okay. It doesn't. Curious. So it's debugging time now. Let's see. We are scaling by context render output size X, and of course, this is the center position, not the size. So context render output size is too big. If we want it centered, we need to divide it by 2. So now render output size by 2 gives us the center coordinate. Oh, I set it to debug and it still doesn't hot reload. Great. But these compilation times are better. Okay, 64 by 64, once again. Flip. I could just save a file instead of redoing it each time, but it is what it is. Okay, yep, it flips, great. So let's change the size and see if it works for a different size. Put it. Okay, yeah, it seems to be working because whenever I move it, it's flipped around the center here. Drawing, yep. Great. Flip node is working, but it's a little boring now. So time for some blow up. Okay, we're gonna leave a backend now because changing the icon, texts, categories, and so on is a purely front-end thing. So we're gonna go to Flipnode view model now, and we're gonna check how things are here. So the very first thing is to maybe specify a category. It's a image thing. So let's maybe put it in the image category, but you can find all categories by going into different nodes and looking what category they are on. So for example, here is structure for image layer node, but there's also here image. The folder structure should also help a little with categories, but as far as I remember, they are not one-to-one. So we need to check. Yep, there is an image. Let's go and define an image. And let's give it an icon, because why not? There is Pixie Perfect Icons class, which contains all the icons inside PixiEditor. There are quite a bit of them. I can show you how to look what icons look like in PixiEditor. So we're gonna use PixiEditor for this actually. So I'm gonna start it, and in the meantime I'm gonna show it where the icons are. So there is PixiEditor UI common in here. Okay, yeah, okay. Let's wait for PixiEditor to start because it's gonna make it a little hard to see. Okay, yeah. Here we have PixiEditor.ui.common, and now in the fonts folder there are a few things. We can see PixiePerfect.ttf, which we are gonna use to preview. So let's maybe close the startup window. Let's go to our rider, and I think I can just drag it from rider. Oh yeah. These are all the icons inside PixiEditor. PixiEditor actually can open font files, so you can preview everything, which is very useful when developing. It doesn't show the names because it's a text. You can select everything. You can type. Oh yeah, it's changed the font, but it opens a font file as a font with all the characters written down. We can convert this to curve, but it's not useful currently. I mean, for our use case right now. Okay, so for flip, is there something that looks good for flipping? I think yes. It's this. Where is it? Oh no, that's not. Let's go line by line. Okay, not here, not here. Oh yeah, there it is. I think this is the one we're looking for. So we have two ways to choose an icon. We can just take it and copy with Ctrl+C, and let's go to the icon. Oh, I did not copy it. Let's try again. Yeah, but this will not work, I think, because we are just copying a character, an actual character. That's why it looks weird. It's better to copy an Unicode. So with Ctrl+Shift+C, as far as I remember, I can just paste. Nope. I don't remember the shortcut, but let's try again. Maybe I'm gonna find it. Oh, I messed up something. Okay. Control. Okay, maybe let's just look at the settings. I think it's in the key bindings. Copy. Nope. Unique. Oh no, it's not a standard. Okay, I'm gonna control. Nope. Or maybe it will work with this. I'm not sure. I just wanted to show that you can do this, but it's not the way that you should do it. The better way is to just use PixiEditor, Pixie Perfect Icons dot and now name. So it's xflip, for example. I'm gonna find this shortcut for copying Unicode. I'm pretty sure it's here. It's in the app. Unless something broke, I don't know. I'm gonna do it in a second, but that's not important. Okay. So, new document and now flip. Oh yeah, there we have it. Beautiful icon. Oh, it has a little dot in here. You can't use normal SVGs or PNGs now. Each icon in the Pixie Perfect icons needs to be converted into a font. So each icon is a part of a font, as you can see in here. It's a little more complicated to add them. I wish it was a little more straightforward. So maybe I'm gonna show it how I am doing this. So let's go to font drop. As far as I remember, yep. No, it's not a font drop. Well, icon, yeah. So there is the icon. I have all the glyphs here already, but it can be imported. There is this pixdevs.svg. If you take this devs.svg in here, it should import. Yep. And all the icons are here, but I don't need it now because I have it already. So let's remove this step. And now when you make an icon, so let's go, I don't know, to Lucite. We are using Lucite icons mostly, but also a lot of custom ones. So if we go to Lucite and select something that looks interesting, for example, Anvil, let's download it. And now when we drag it here, it should add it. There is an information that stroke gets ignored when generating fonts. Oh, use the new app instead. Oh, they made new app. Maybe it will work without custom action. Let's check their new app. Okay. This is the first time I am using it. No idea what's gonna happen. Okay, still I dropped the devs in here. I have all the icons. And now, I don't know, let's drag this Anvil. I just downloaded it. Oh, there it is. Maybe it converts the strokes automatically. That would be great. I had to do it manually previously, which was annoying. But basically now we should be able to export it. So there's an export. And when I download this, let's see. Oh no. Okay, untitled project. Okay, yeah. So we have now a fonts, and there is TTF, which we would now drag into PixiEditor, but there should be an SVG. Oh, each SVG is separate. Curious. As I said, I did not use the new app yet. There should be an SVG with all the icons. I wonder if I enable this and it's gonna load. Oh, there's devs.svg. Maybe this is what I'm looking for. Come on. Why you don't work? Okay. There is... Oh, it's... Oh, empty. Okay. Interesting. Well, I suppose... oh, it's a zip, that's why it's not loading previous. But, well, if you use the old app, not the new one, you're gonna get a one SVG with all the icons. It's a matter of dragging it into fonts. Then we need devs.svg, this name is important, and also PixiEditor.ttf. Once you move it there, then there is generate icons Python script which you need to run, and it's gonna recreate like every icon in the PixiEditor codebase. It automatically it's gonna get generated, so you will be able to access it via PixiePerfectIcons. This basically. So yeah, I think this is, well, this flip node could use one more thing though, or even two things. Let's start with maybe more interesting one, which is adding another parameter, because why not? We're gonna specify in here, is it scaling, I think, or maybe center position. Yeah, center position is better to define. Or maybe offset. Oh yeah, let's make an offset. So let's create another input property, which is gonna be a vecd. Vecd is basically a vector of doubles, so it's a x and y. That's it. That's the whole structure. X and y, a vector, coordinates, size. You choose. Okay, let's maybe call it offset. And now offset equals, and now create input, not render input because it's a normal input. We can call it offset. Now display name also offset, and the default value will be 0 because by default we want it to be in the center. And now we can just add offset in here. So offset dot value dot x plus offset dot value dot y. It's double, and we need float, so we're gonna cast it to float. Not in here, in here. And let's rerun everything, and we should get another input. Okay, let's see. Oh, it remembered my file, great. As you can see, I have this flip node previously in the file, and PixiEditor restored this file, and the offset input still added. So it of course works with the old files, not only new ones. Because PixiEditor internally recreates each node when you open the file. Okay, so let's test if it works now. here we have the flipping. So now let's put an offset. Oh, great. Y doesn't seem to be working, but X does. Or maybe it works, but just preview is messing it up. Let's see. Nope. Okay. Interesting. Okay, yeah. The Y is 1, so I think it makes... No, it does not make sense. Or it makes sense? The code looks fine, so it probably makes sense, but I don't see it now. It flips X. I wonder if I change the Y to -1, because it now should flip it vertically too, not only horizontally. Is it gonna restore the file? Let's see. Yeah, but the old snapshot. That's fine. Oh, okay, yeah, it's flipped in Y2 now. So X works, and Y, oh yeah, it works too. So I suppose it was just a matter of setting the scale. It was 1 previously in Y, so I think it makes sense that changing Y offset did not work. Now it works nice. But as you can see, it's pretty easy to make a node that does something. The code is not difficult. It's a matter of understanding how much matrices work and how to generally take the inputs and outputs in PixiEditor. There are a lot of stuff that you may discover when you create something, a custom node. So, for example, you can make some validations. So, for example, I can specify here the with rules method, which will allow me to define some rules. So, for example, I can make it so offset cannot be negative. Because why not? Let's check vegd.0. Let's say minimum value. Let's see. Okay, so now offset, I don't need to connect it even, I'm just gonna play around. So I can make it positive, but it does not allow me to go negative. So here's an example rule. You can also use max and so on. There's also custom rules, custom, I don't even remember what else here, but yeah, a lot of stuff that you can just play around in the actual node, but overall a render node is just a wrapper. The basic unit is normal node. It contains only on execute, not on paint. So when I remove the render from here, this is now not needed, and there is on execute. So you can make a rendering nodes or nodes that are working fully with CPU. There are also functional sockets. So these are the diamonds that you can see in the documentation, which are here. Yeah, diamond sockets. They basically are GPU context sockets. So with them you can make custom shaders, because they don't contain normal values, they contain functional values, let's call it like that. Blender has something similar. I don't remember how it's called, but the idea is the same behind them. Maybe let's find it. Blender sockets, diamond. Okay, why not sockets? Yeah. No name. But I think this is yeah, if you can find some info on this in Blender, this works very similarly. So basically, a diamond socket from a math node means that it will work for each pixel in begin modify image. Maybe not math node, but here we have a color of individual pixel in whole image. Again, you can see the documentation. Also, the best way to learn how nodes work is to simply go to the code and see how things are implemented. Let's go to, I don't know, maybe a math node. So math node contains a func output property, func input property. So these func inputs and outputs are basically these diamonds, and yeah, a lot of stuff in here. You're gonna use the func inputs if you're working with GPU context. Maybe another time. This is a little more advanced, so I don't think I'm gonna cover it, but it's good to be aware. Okay, one more thing that is pretty useful if you want to contribute to PixiEditor Codebase with new nodes is to use localization, because right now we have hard-coded flip in here. So now, no matter if I change the language, then flip is gonna stay flip. As you can see, the other nodes change to Polish, but not our flip. Even better, you can go into debug menu. To enable it, you need to go to edit, settings, and enable debug mode. So debug, and there is open localization debug window. And with this little drop down, we can check whether inputs or text is localized or not. As you can see, for add, for math node, there is add, and in the parentheses math underscore add, which means that this is a math underscore add key in here. But with flip, there is nothing. I mean, there is flip, but it's not a key. It's not a proper key. It's hard-coded. If you select key, you can see all the keys are in the screaming case. So all uppercase with underscores. Flip is not. So let's come back to the original thing and let's make it a key. So in PixiEditor project, there is a end.json, or I don't see it here. Wait, I don't remember. I always search it in the Rider because I don't want to navigate the tree. So it's in PixiEditor data localization languages. PixiEditor data localization languages, and there are other languages. One important note about localizing. In the code base itself, you shouldn't change any language besides English. English is the only language that you should be editing in the code base. The rest is updated, maybe not automatically, but we have this separate service on which translators are translating texts to other languages, and then we download them before releasing and update in the code base. So if you change anything in your language in here, it's gonna be overwritten besides English. English is the only one that we need to change in the code base. So let's scroll it to the bottom and let's add our flip. We have flip in here, so let's call it flip node maybe, and let's go flip. So now I've added a new entry to the translation, so I can now close it, and in here just type out the name, the key, flip node. So now when I run it, it should look at the end.json, look for flip underscore node, and use its value as a text. Let's go. Flip. Yeah, it's flip again. It's not screaming at us. So let's go to debug, localization, debug window, and use key. Yep, it's flip node. Perfect. I mean, if you change the language to Polish, for example, it's still gonna stay flip because there is no translation in Polish. That's why it's not changing. It's falling back to English again. But once it's gonna be in the translations, it's gonna use the Polish translation for Polish, of course. So yeah, this is basically the big TLDR for maybe not TLDR overview of creating nodes. It's really fun. You don't need to know a lot about the whole code base to create something cool. So I really encourage to play around creating nodes and making something cool. If you have any questions, always you can go to our Discord and ask us. Basically, I'll be more than happy to help with all the node stuff, and not only. So feel free to write, and I'll be making another Codebase live streams. Not sure yet exactly. I'm not sure when. Yeah, exactly, but soon. Maybe we'll create some tools. We'll see. But nodes are already like a lot. You can make really a lot with them. So yeah, I think that's it for today. I'm gonna stay for like 5 more minutes if you guys have any questions and play around a little here. So feel free to write, and that's it. Thank you for watching. I'm gonna check if this drawing tablet works and why it doesn't. Ah, lovely Windows. I just wanted to draw. Okay, I'm just gonna like. Oh. Okay, I'll put a Discord link in the chat. Have questions. Yeah, so there is a Discord link in the live stream chat. So if you have any questions about development or all different things, then please join and let's chat. I'm really more than happy to play with your creations and help debugging and so on. Okay, I suppose then there are no questions, so thank you again for watching, and see you next week. There will be a live stream about the noises, so if you're interested about noises, come back next week. See you.